Okay, so this is going to be the review for the Chapter 6 test, which is on radicals. Okay, the first question is going to look something like this. It's going to say, find the square roots of 36. So when it's asking you that, it's asking you what number, if you multiply it exactly times itself, gives you 36. Okay. Also, if you notice, there is a button on your calculator that will find the principal square root. So if you push this second button, and then if you'll look right over the x squared, there is that little square root symbol. It'll give you that radical symbol there for you. So if I'm finding the square root of 36, just put the 36 under the radical, hit enter, and that'll tell you 6. So make sure that that's the principal, because 6 is when you multiply it times itself, it gives you 36. So the principal square root would be 6, and then it's going to ask you the negative square root, which would just be -6, because if you think about it, either one of these numbers, if you multiply them times their self, what is 6 times 6? Well, it's 36. Also, what's -6 times -6? Well, it's also 36. So that's why 6 and -6 are your answers. Okay? Number 2 is another square root problem. This one has a couple of new things. It's got a negative, but it's on the outside of the radical. And what's underneath the square root is a fraction. But if you will notice, when you're looking at the two numbers of this fraction, they are both perfect squares, right? So this negative that's on the outside, it's just going to come over. It doesn't have anything to do with what's going on underneath this square root, okay? So what times itself gives you 100? That'll be 10. And what times itself gives you 49 would be 7, right? Because 7 times 7 is 49. So the answer would be the negative that just came over, and then the square root of the top and the bottom would have been 10 over 7. So -10 over 7. All right, number 3 says find the square root that is a real number. So this time you have a negative underneath 64. Now, this right here, when you have the square root of a negative and it's asking you for a real number solution, this is because there is not a real number. If you multiply it times itself, you can't use a real number times itself to get -64. So it is just not a real number, right? Because in order to get that negative, you need a negative number times a positive number, which is that's not the same number then, if one's negative and one's positive. So the answer would be not a real number. All right, number 4, this time the radical looks like this. And when you have a number in here, what you're trying to find is what number times itself 3 times gives you what's underneath. So let's say it's the cube root of 27. That would say I need to know what the number is times itself 3 times that is 27. So you can do cube roots in your calculator. If you hit the math button and then go down there and look at number 4. That right there is a cube root symbol. So hit enter. So see how I put the little 3 in that little house to give you the cube root symbol instead of the square root symbol? That's what you want if you're taking a cube root. So hit, let's see, 27 is what we're finding the cube root of. Hit enter, and you'll see your answer is 3, right? Because so that answer would be 3, which is telling me what? What does that mean? 3 times itself 3 times should be 27. Well, 3 times 3 is 9. And then 9 times 3 is 27. So that's why 3 is your answer there. All right, number 5, another cube root. -512 x to the 3rd power. So we can't do the x in the calculator that I know of, but I could do the cube root. I could do this number part. So let's go again. Hit your math. Go down to number 4 to hit your cube root. So I'm at cube root. We'll type in -512. So -512. Now remember, when I had a square root and a negative underneath, my answer was not a real number. But look what happens if you have a cube root of a negative. It does give me an answer. Okay, if you take the square root of a number, it gives you an error message. But the cube root can happen, right? It's saying -8 times itself 3 times is -512. Because you can multiply a negative number times itself 3 times and end up with a negative, right? Because what's -8 times -8 times -8? Well, -8 times -8 is +64. But when you multiply that 64 times -8, it does give you -512. So it will work. Now, here's the shortcut to your exponents. You want to divide your exponent by whatever root you are taking. So if I'm taking the cube root, I want to divide that exponent by 3. That will give you what the cube root of that is. So what happens when you divide 3 by 3? You get 1. So the cube root of x to the 3rd is just x. So -8x would be your answer. All right, number 6 says rewrite without rational exponents. And I have x to the 1/7 power. So this is what a rational exponent looks like. It's got an exponent that is a fraction. So it wants me to rewrite this as something where the exponent is not a fraction without rational exponents. And here's the thing, you can go back and forth between rational exponents and radicals, which are the little square root and cube root and whatever root symbols. So here's how you do that. This, whatever is right here, is what's going to be underneath this symbol. So you're going to have an X underneath there. Whatever number this is in the denominator of your exponent, that's the number that goes in your little house right there. It's called the index. So this right here, x to the 1/7 power, is the same thing as hitting the 7th root of x. Now, if this was anything other than a 1, like if that was 2/7, whatever this number is the exponent underneath there. So if it would have been 2/7 right there, you would have put that 2 right there. But since it's a 1, technically if you put that 1 right there, what is x to the 1st power? Well, it's still just x, so there's no need to write it. But if there was any other number there, you would put whatever that number was right here, okay? So x to the 1/7 power is the same thing as the 7th root of x. Now, you may have some issues typing this into Math Lab. Now, remember, if you're typing square roots in, you use down in your toolbox, it'll have a square root symbol with the blue box underneath there, and you put your answer right there. Any other one, the symbol that's right next to it has the blue box here, but it's also got a little blue box here, which means you can put the x underneath the radical, but this little 7 you can put in that little blue box. That's so small you can't see it. But you know what I'm saying. If you're typing in anything else, you want to be able to have that blue box to put that number in right there. All right, number 7. Rewrite without rational exponents and simplify if possible. I've got 81 to the 3/4 power. So just like the last one, I'm going to go from a rational exponent, which is an exponent that's a fraction, to a radical symbol. So let's see, there's my radical symbol that I'm gonna fill in. Whatever this base number is, that's what's coming right here. So I have 81. Now remember where this number came from. It was whatever the bottom of that exponent was. So that's gonna be a 4. Now remember, we talked about it on the last one. It's just that the last one had a 1 up here, which means it didn't really affect anything. But this time, right here, since that's a 3, we do have something that we need to put down there. Now, since this is a number instead of an x, I can simplify this. I need to find out what is the 4th root of 81 to the 3rd power. So the first thing I need to do is find out what is the 4th root of 81. So let's talk about how to do that. So we did the math button, and we saw that number 4 was a cube root symbol. Look at what number 5 is. See how it has that little X there instead of a number? That means we can put in any number we want right there. So what do I want to be there? I want it to be a 4. Now, here's the trick. Clear this. Before you hit the math button, hit whatever number you want to be in that little X spot. So you want to type in 4th root. So watch what happens if you hit the 4. Now go to your math button. Go down to the 5th one. So look what it's going to do. It's going to put that 4 in that little house, because I already told it I wanted that X to be a 4. So I want to type in the 4th root. Now I want to put the 81 underneath there. So 4th root of 81 and hit enter. So now I'm to a 3. But here's the part that I've taken care of. I've done the 4th root of 81. That gave me the 3. Now, what do I need to raise the 3 to? This 3rd power. So now, just hit 3, your answer to the 3rd power, and hit enter, which gives you 27. Because 3 to the 3rd power, so the 4th root of 81, that turned out to be 3, but I still have this 3rd power here. So 3 to the 3rd power gave me 27. Okay, let me try. Let's see. Okay, look, you can actually do it all at the same time. If you type in this whole thing all at once, which means, let's see, I'm going to clear that out. I want to type in 4th root, which means, remember, you'll have to hit the 4 first, go to your math button, then go down to number 5, hit enter. So there's your 4th root. What do I want to type in under that 4th root? I want to type in 81 to the 3rd power. So just type it in exactly like that. There's your open parentheses. 81, close your parentheses. Now I want to put it to the 3rd power. So remember, just hit this. This gets you up into your exponent. So exponent 3. So see how what's in my calculator looks exactly like what's on the board. The 4th root of 81 to the 3rd, and hit enter. 27. Okay, so you can do that all in one step. All right, number 8. This one says write with rational exponent. So let's see, I've got the 7th root of 20. So now we're going opposite, okay? So anytime you are going from the radical to a number that has a rational exponent, which just means it's going to have a base, and then the exponent's going to be a fraction. So whatever is right here, that's going to be your base number. Your main number is 20. Now remember, your exponent is going to be a fraction. So let's see, what is going to be the top and the bottom of that fraction? Remember this number that was on the bottom of the fraction, where did it end up going? It was this number, right? So whatever number is in your little house right here, that's the bottom of your exponent. Now remember the top of the exponent was whatever exponent you saw right here. I don't see one. What does that mean that 20 is being raised to since you don't see an exponent under there? It's being raised to the first power. So the 7th root of 20 is the same exact thing as saying this 20 to the 1/7 power. Now, when you're typing this into Math Lab, you're going to have to type in the 20, and then you're going to have to go and tell it you want to go up into the exponent. Now, when you get into that exponent, you'll be able to just hit 1/7 or 1 divided by 7. That will make your exponent that 1/7. Hang on, I need a drink. All right, number 9. Rewrite 64 to the -1/2 power with a positive exponent and then simplify. Now, if you have a negative exponent, that means whatever is being raised to that negative exponent needs to go to the other side of the fraction bar. Well, that's funny because I don't see a fraction here, which means I need to think of that 64 as being over 1, right? Because that's the same thing as 64. Well, if I am a number and I have a negative exponent, whatever's being raised to the negative exponent needs to go to the other side of the fraction bar. That makes its exponent positive. So if everything goes to the bottom, that means you're left with that 1 up top. You can just think of this as flipping upside down. Now, we've got to simplify this. So let's think about what that means. The top stays as a 1. What does 64 to the 1/2 power mean? Let's think about that as a radical. That doesn't mean half of 64. What it does mean is the square or second root of 64. So let's think about what that means. That would have a 1 still up top. And what is the square root of 64? What number times itself is 64? That would be an 8. So 1/8 would be your answer. Okay, now starting with number 10. It says to simplify by factoring. Now, here's the deal. Everything that we've worked with so far, if we were doing square roots, it would be like the square root of 25, and it would give me an answer, 5. But what happens when you put in the square root of 150? It gives you a long decimal. That is not what it's going to want as its answer. So here's what it's going to want you to do. It's going to want you to break this number apart into 2 square roots. Here's the deal. The 2 square roots have to multiply to equal 150. So remember when we were factoring and we needed to find all the ways to multiply to get a number? I can do that here. So remember, how do we do that? Go to your y equals and clear it out. I want to know all the ways to multiply to get 150. So I'm going to type in 150 divided by x. That's all I need to know. So let's hit second and then hit your table button. Look what it gives you. It gives you all the different ways to multiply to 150. Now, here's what I'm looking for. The number that you put in this first square root has to be a perfect square, which means you have to be able to take the square root of that number. So what are your perfect square numbers? Your perfect square numbers are 1, 4, 9, 16, 25. Those are all perfect squares. So let's looking in these columns. Which one of those numbers can you take the square root of? So I'm going to go down until I see it. Let's see. Not counting 1. 1 doesn't help us. 2 and 75. Neither one of those are perfect squares. 3 and 50. Neither one of those are perfect squares. 4 has a decimal with it, so that doesn't work. 5 and 30. Can you take the square root of either one of those? No, not and get a whole number. But look at this next one. You have 6 and 25. Look at that 25. Can't you take the square root of 25? Isn't that a perfect square? It is. I can take the square root of 25. So I'm going to put that number here. And then 25 times what is 150? Well, look at what its pair is. 25 times 6 is 150. Now you made a perfect square, which means now you can take the square root of it. What is the square root of 25? Well, it's 5. This is just considered like trash. Whatever you put over in that leftover one, you put it there because you can't simplify it anymore. So this right here will always just drop down. So 5 square root of 6 is your answer. All right, number 11, same thing, the square root of 300x to the 4th. So again, 300 is not a perfect square. That's why I'm breaking it up. So let's type in 300 in our y equals. So again, you'll have 300 divided by x. Second table. Look how many ways, oh, sorry, my bad. There is to multiply, and I can even go down from here. So what I'm noticing is, let's see, 2 times 150, no, that's not gonna help me. Neither one of those are perfect squares. Look at this next one, 3 times 100. That 100 is a perfect square. Now let me just show you what you don't want to do, because look at the next pair. You've got 4 times 75. Well, 4 is a perfect square also. So I'm in a situation where I have more than one number that goes into 300 that's a perfect square. If that is the situation, you always want to go with the highest. Since 100 is the highest perfect square factor, that's the one you're going to choose. So I'm going to put the 100 here as my perfect square. 100 times 3 is 300. Now I got to deal with this x. Now remember, the way that the shortcut to take the square root of an exponent is you want to be able to divide it by 2, right? I want to be able to divide that exponent by 2. Can you divide this exponent evenly by 2? You sure can, okay? Which means this whole thing is a perfect square, which means it can all come in that front radical. Again, you don't want to put anything in here that's going to make it to where you can't take the square root of it, okay? But I can take the square root of this. So what is the square root of 100? It's 10. Divide your exponent by 2. So when I divide that exponent by 2, I get x squared. Remember, this is trash. It just always comes down. So 10x squared, square root of 3. Number 12, same thing. Square root of 32, a squared b. So again, breaking it up, since 32 is not a perfect square. So again, go to your y equals, clear out that 300, do 32. Oops. Divided by x. Second table. Here's all the ways to multiply to get 32. You're looking for a perfect square. Again, I see more than one number in there that's a perfect square. I see a 16 and I see a 4. Both perfect square numbers. Which one's higher, the 16 or the 4? Well, 16 is obviously higher than 4. So 16 is the perfect square that I am going to use, that 16. So I'm putting the 16 here. 16 times 2 is 32. Now let's deal with the A's and B's. Can you divide this exponent by 2? You can, which means the A's need to come here. So A squared there. But look at the B. Here's what happens. If you put B in this square root right here, you're going to be stuck on the next step because that B is going to mess you up because you can't take the square root of B and get a whole number answer. So that's why this B needs to come over here with the 2 in the trash. Now, take the square root of your perfect square. The square root of 16 is 4. Divide your exponent by 2. So if I divide that by 2, I get a 1. So 4a. And drop down your trash, square root of 2b. And again, remember, just pause me if you need to stop and look at that for a little while. Number 13, the square root of 3b to the 5th times the square root of 15c to the 6th. So it says to multiply and then simplify. Now, when I'm multiplying radicals, it doesn't matter what's underneath here. I can multiply whatever that is. So I'm just going to multiply those square roots together and turn them into 1. 3 times 15 gives me 45. Then I've got b to the 5th and c to the 6th. So b to the 5th, c to the 6th. Now I'm going to do to my answer what I've done in the last couple of problems. I've just got to break it back apart. But this time I'm breaking it apart to its perfect square and leftover. So let's see, I'm trying to break apart a 45. So go back to your y equals and do 45 divided by x. Second table. So there's all your ways to multiply to get 45. So let's see, 3 and 15. Neither one are perfect squares, but go down to the next factor pair, 5 and 9, right? 9 is a perfect square. I can find a number that multiplies times itself to get a 9, which means it's a perfect square. So I'm going to break up my perfect square. Part of this is 9, which means my leftover is 5. Now, because 9 times 5 gives me that 45. Now, here's what you're going to have to do with these b's. I want to put as much of this as I can in my perfect square, but still have my exponent to be able to divide evenly by 2. Which means if I've got b to the 5th, since that doesn't divide evenly by 2, doesn't work, right? Doesn't divide evenly by 2, which means I can only put part of this. But again, you want to put as much as you can. So I'm going to put b to the 4th there because that can divide by 2, which will leave me with 1 left over in the trash because, right, b to the 4th times b gives me that b to the 5th. So again, I put 4 here, which left me with 1 in the trash. Now look at your c's. Can you divide this exponent evenly by 2? You can, which means all of the c's can come here. So all of c to the 6 comes in your perfect square radical. Now, let's simplify my perfect square. The square root of 9 gives me 3. Divide your exponent by 2. So let's see, the b will turn into b squared. The c turns into c to the 3rd power. And then again, as always, whatever you put in your trash just drops down. So that square root of b to the 5th just drops down. So again, 3b squared, c to the 3rd, square root b to the 5th. Number 14, divide and simplify. The square root of 490 over the square root of 10. So if you have a number, a fraction, the first thing you're going to do is see if 490 does divide by 10. Does it divide evenly? It does, which makes this a much easier problem. Just go ahead and divide the top by the bottom. So the square root of 490 over the square root of 10 just gave me the square root of 49. And 49, as luck would have it, is a perfect square. What times itself is 49? Plain old 7. All right, number 15. You're adding radicals this time. 8 square roots of 5 plus 4 square roots of 5. Now, when you are adding radicals, here's the first thing you're going to check for. Are your radicands, which are these numbers underneath the square root symbols, are they the same? If they are, that means that this term and this term are like terms. So you're just putting them together. You're combining like terms. Let's see, if you've got 8 square roots of 5, and then you add to that 4 more square roots of 5, how many square roots of 5 do you have? Well, you've got 8 of them here and 4 of them there, which means all together you've got 12 square roots of 5. So you're just putting your square roots of 5 together. Now, when we get to 16, hang on. We're still adding, well, subtracting actually. 5 square roots of 18 minus 8 square roots of 2. Now, unlike the last one, our radicands are not the same, which means I can't just put them together as simple as I could on the last one. But remember the simplifying, how we break apart radicals to perfect squares and leftovers. Let's do that with these and then see if we can add them together. So let's see. This 5 will just come down. Now let's see if this square root of 18 will simplify. Now remember, if you're simplifying, that means you have a perfect square factor. So let's see. Let's go to our y equals and put in 18 divided by x second table. Here's all the ways to multiply to get 18. Let's see. The first way is 18 times 1. Again, 1 doesn't help us, even though it's a perfect square. But look at that second row. You've got 2 times 9. 9 is a perfect square, which means I can put it here. 9 times 2 is 18. Now, what's going to come out of this right here? What is the square root of 9? What's 3, right? 3 times 3 is 9. So let's see what we're going to have. This 5 just comes down. Out of here is going to become a times 3. Drop down your square root of 2. Remember, it's trash. It's just going to come down. So this square root of 9 turns into a 3. Now look what you have here. You've got 5 times 3, which gives you 15. And then drop down your square root of 2. Now, bring down this minus. Look at this other one. It is a square root of 2, which is like this one, which means I don't want to mess with this one at all, because if I just drop down that 8 square root of 2, look, my radicands are the same now, so they are like terms. So I'm going to have how many square roots of 2 left? Well, let's see. I've got 15 here, minus 8 here. So 15 minus 8 gives me 7 square roots of 2. All right, number 17. All right, so this one's the same kind of problem. It's just going to have 3 of them. So I'm going to have to write a little bit smaller. 8 square roots of 300 minus the square root of 27 plus 5 square roots of 243. So let's see. I can't put any of those together right now, right? None of them have the same radicand. So let's do what we've been doing. Bring down this 8. Break apart the 300. So let's see. 300 is what you're breaking apart. So in the y equals 300 divided by x. 300 divided by x Second table. So here's all my ways to get 300. So let's see. 2 and 150, no, but look at that. There's a 100. That's a perfect square. So let's use that. So I put the 100 here. 100 times what is 300? 100 times 3. Now let's keep going with this. This 8 just comes down. Now let's see, what's going to come out of that square root of 100 right here? Well, the square root of 100 is 10. So you're going to have times 10 there. Bring down this square root of 3. So now here you've got 8 times 10, which gives you 80. Bring down your square root of 3. So this right here, 8 squared root of 300, when I worked it out, broke this up to 100 times 3. Then the square root of 100 turned to 10. Then I had 8 times 10, which was 80. Again, once I made this square root of 3, it just dropped down the whole time. Now, let's look at this next one. Minus, since there's no number in front of here, I don't need to bring anything down in front of that. So let's see, the square root of 27. I'm trying to break apart a 27. So go back to your y equals, clear it out. 27 divided by x is what I'm trying to find. Second table. So let's try to find a perfect square. Whoops. Let's see. There's a decimal. Look at this one though. 3 times 9. 9 is a perfect square. So let's put the 9 in the perfect square spot. 9 times 3 is 27. Bring down this minus. What's going to come out of the square root of 9? What's the square root of 9? Well, it's just plain 3. And then drop down that square root of 3. So I'm done with this next one. All right, this last one, drop down the plus 5. Now you're breaking apart that 243. So I definitely would go to y equals on this one. 243 divided by x. So 243 divided by x. Second table. So let's start going down. Let's see. That one's a decimal. But look at this next pair. 81 times 3. Isn't 81 a perfect square? What times itself is 81? 9 is. So 81 is a perfect square. So it'll come here. 81 times 3. Let's see. Bring down the plus 5. What's going to come out of that 81? You're going to have a 9 come out of there. Can you see that? So a 9 comes out of that. Drop down your square root of 3. So bring down this plus. What's 5 times 9? It's 45. Drop down your square root of 3. Now look at your 3 terms. They all are square roots of 3 now. So they are all like terms. I just need to figure out how many square roots of 3 I have. Well, let's see. I've got 80, then I've got minus 3, and then I've got plus 45. So I just typed that all in. Add 80 minus 3 plus 45, which gives me all together, I have 122 square roots of 3. You definitely may want to pause that to look all the way through it again. All right, number 18. Multiply. You've got the square root of 3 times 2 minus 10 square roots of 3. So here's what I'm doing here. I'm going to distribute this square root of 3 to both of these terms. Now, when you're multiplying, do you see how this 2 is not underneath a square root, right? So that means I don't multiply the 2 and the 3 together. If that 2 had a square root around it like that, then the square root of 3 times the square root of 2 would have been the square root of 6. But since that's just a plain 2, you have the square root of 3 times 2, which is just 2 square roots of 3. Bring down the minus. So now the square root of 3 is coming here. So again, it's like there's a 1 in front of that. So you're multiplying the numbers in front of the radical together. So 1 times 10 gives you 10. And then the square roots together. So this time I do have a square root times a square root. So 3 times 3 gives me 9. Now let's see what I can do to simplify this. The square root of 3, is it a perfect square? Is the 3 a perfect square? It's not. And it doesn't have any perfect square factors other than 1, which means it also won't break apart. So there's nothing I can do with that one. Now, I can bring down this 10. Now, what is the square root of 9? Isn't 9 a perfect square? The square root of it is plain old 3, right? So this ends up being 10 times 3, which gives you 30. So you have 2 square roots of 3 minus 30. All right, number 19, again, another multiply. Got the square root of 10 minus the square root of 3 times the square root of 10 plus the square root of 3. So this one, I'm actually going to FOIL, right? I've got 2 binomials. So let's see, I'm going to multiply. Square root of 10 times square root of 10, which gives me the square root of 100. Right? Since both 10s are underneath the square root, I multiply them together. Then I've got this square root of 10 times positive square root of 3. So that's going to give me positive. Since they're both under the square root, I'll multiply them together to get the square root of 30. My inner, let's see, negative square root of 3 times the square root of 10. So that's going to be minus, multiplying that together, which gives me the square root of 30. And then my last, negative square root of 3 times positive square root of 3. So the negative times the positive gives me negative. Multiply the square roots together to get the square root of 9. So let's see how we can make this cleaner. Let's see, look at your middle terms. It doesn't matter what they are. If positive of something combined with the negative of that same thing, so those are just going to cancel, right? Now look what you have left here. The square root of 100 is plain old 10. Bring down this minus. The square root of 9 is plain old 3. So now you're left with 10 minus 3, which is 7. All right, number 20. Another multiply, FOIL. Have the square root of 11 plus 3 square roots of 8 times the square root of 11 minus 3 square roots of 8. So I'm going to FOIL this again. Let's see. My first, square root of 11 times the square root of 11. Since those are both underneath the square root, it's going to multiply the 11s together to get the square root of 121. Now my outer, here's where it gets kind of tricky. So let's see, I've got the square root of 11 times negative 3 square roots of 8. So first of all, it's a positive times a negative, so it's going to be negative. In front of my square roots, I've got 3 times, pretend there's a 1 there. So 3 times 1 gives me 3. Underneath my square roots, I've got 11 times 8, which gives me the square root of 88. So again, 3 square root of 88. Then my inner, let's see, again, in front of my radicals, this time I have positive 3. And then my square roots give me 88. And then my last, let's see, in front of my square roots, I've got positive 3 times negative 3, which is negative 9. And then my square roots, I've got square root of 8, square root of 8, which gives me square root of 64. Now we've got some cleaning up to do. Let's see. Again, just like the last problem, this one cancels that one, right? Negative 3 squared root of 88 and positive 3 squared root of 88 will just cancel each other out. So I've got the square root of 121, which is 11, because 121 is a perfect square, right? 11 times 11 is 121. Now, look what you have here. Okay, this minus 9 comes down. What's coming out of this? What is the square root of 64? Well, it's an 8. So now you have negative 9 times 8 right there. So you've got 11 and then minus 72. So I would just type that again in your calculator. 11 minus 72, which gives you negative 61. All right, number 21. Rationalize the denominator. So I've got the square root of 10 sevenths. So sometimes this number will divide evenly by that one, but 10 doesn't divide evenly by 7. It gives you a long decimal. So that's when you rationalize the denominator. And the way that you do it is whatever that denominator is. So think of this as two separate square roots. The square root of the top and the square root of the bottom. These two things say the same thing. Whatever the square root is in the bottom, you can just multiply by that on top and bottom. Because what you're trying to do is turn that denominator into a perfect square. And if you multiply it times itself, it will be a perfect square. So let's see what we get up top. 10 times 7, so the square root of 70 over 7 times 7 gives me the square root of 49. So let's see, I'll keep the top the same, square root of 70. But, so 7 times 7 gave me 49, which means the square root of 49 is plain old 7. So you have the square root of 70 over 7. Number 22. Again, rationalize the denominator. You've got 10 square roots of 7 over 7 square roots of 5. So again, we're just trying to make sure that that 5 turns into a perfect square so that I can take the square root of it. So whatever that square root is, that's what you're going to multiply by. So let's see. Up top, I've got 10 square roots of 7 times the square root of 5. So when you multiply those square roots together, you'll get 10 square roots of 35. Over 7, multiply your square roots together to get 25. So now let's see, remember we turned that 5 into this perfect square. So what is that really saying over here? What is the square root of 25? Well, it's just plain 5. So this really says 7 times 5, which gives you 35. So we have a 35 as our denominator. So let's see, let's rewrite this and see what we have left. Up top, we have 10 square roots of 35. In the denominator, we've got plain 35. Now, it's like this square root is protected underneath its little house, so I can't do any division because this one doesn't have a square root. But I can simplify the 10 over 35. And remember how to do that. Just type in 10 over 35. Get your crazy decimal. And then just math enter that. So math enter to see that 10 over 35 will reduce to 2 sevenths. So what are you left with up top? 2 square roots of 35. And what are you left with in the bottom? Plain old 7. So 2 square roots of 35 over 7. All right, number 23. 23. You have the square root. Oh, now we're solving equations that contain radicals. You've got the square root of x plus 1 equals -6. Now, remember when we talked about this, if you had the square root and it was equal to a negative, you would work this out and actually get a solution. It's just that when you tried to plug it back in, it would not make this equation work. It wouldn't make a true answer, because if you have a square root equal to a negative, that is when there is no solution. All right, number 24. The cube root of 2x plus 6 plus 8 equals 9. So on this one, when you're solving a radical equation, if there's anything outside of the radical, you want to remove it first. You don't want to try to mess with it on the same side of the radical. So before I do anything else, I'm going to subtract that 8 off of both sides. So now I'm going to have the cube root of 2x plus 6 equals, on the right, let's see, I've got 9 minus 8, which is 1. Now, remember how we get rid of radicals. Whatever root you're taking, to knock it out, raise it to that same power. So if I raise this side to the third power, I've got to raise this side to the third power. So let's see, this third power cancels out that cube root. So you're just left with what's underneath here, which is 2x plus 6. Now on this side, 1 to the third power just means 1 times 1 times 1. And what is, it doesn't matter how many times you multiply 1 together, you're still going to have 1. And then just finish solving it for the x. So subtract the 6. So now you have 2x equals 1 minus 6 gives me -5. And then divide it by 2. So now you're left with x equals, all that's left over here is -5 over 2. All right, last one. Number 25, another radical equation. This time I have square roots on both sides. I've got the square root of 7y plus 3 equals the square root of 6y plus 5. So I don't have anything outside of the square root. So I'm going to go ahead and cancel the square roots. How do you knock out a square root? With a squared. If I do it to one side, I have to do it to the other, which actually works out nice for us because the square knocks out the square root there, and the square knocks out the square root there. So it's essentially just releasing what's underneath the radicals. So I'm just going to have 7y plus 3 equals 6y plus 5, and then finish solving for x. I mean y in this case, y. So we'll have y's on both sides. So I need to I'm going to cancel out my small y. So I'm going to subtract 6y from both sides. 7y minus 6y is just y. Bring down the plus 3 equals 5. Getting y by itself, so all I need to remove is the plus 3 with a minus 3. So what are you left with? Y on this side equals 5 minus 3 is 2 on that side. So your answer is 2. So if you've listened to this whole thing, send me an email and tell me to give you a bonus point on the Chapter 6 test.